Now, typically, if we want to plot a complex number, we plot it on a rectangular axis where the x-axis, horizontal axis, is the real axis, and then the y-axis or the vertical axis is our imaginary axis. So if I have a plus pi or 5 plus 7i, then my imaginary number z, instead of saying it is a plus pi, I could say that it is x plus yi, and in this case x, or my real part, is the 5 in my imaginary parts, y is 7, or you can think 7i, and if I wanted to plot this, I would go along the real axis, my real part, or in this case 5 units, and then I would go up along the imaginary direction or the imaginary axis, my y part, or 7 to this point right here. This is the point z. Now when you take the absolute value of an imaginary number or complex number, remember that the absolute value is the distance that point the form the original. If we were taking the absolute value of 5, well, that's just 5 because it is 5 units away from our original. If we want to find the absolute value of complex number, though we would want this distance is the absolute value of z. Now if I want to find the absolute value of z, I can think of this kind of like triangle, and then I can use the distance formula, or I can use Pythagoras theorem because this is the right triangle. So I take my x part and I square it, and I added that to my imaginary part, or my y part, which is also squared, and I take the square root. This is the square root of 25 plus 45, 49, or the square root of 74, which, if you are curious, is about 8.6. Well, you may notice that finding the absolute value of our complex number is a lot like converting our complex number into a polar coordinate system. If I set this absolute value of z, that would also be distance r, and then all I would need is a theta value. Remember, when you convert from rectangular to polar coordinates, this x value here, this is always equal to r times the cosine of theta, our hypotenuse length, times the cosine of this angle, and then our y value. This is always equal to r times the sine of theta. But remember that we are going in the imaginary axis. This is not the y-axis. This is the imaginary axis. So even though I am calling this y, this is really r sine theta times I times the square root of -1. So if I wanted to, I could take this form and can say z is equal to r cosine theta plus r sine theta times I. This is x, this is y, and if I factor out on r, I will get z is equal to r times the cosine of theta plus I sine theta. Well, this is how you write complex numbers in polar form. If I wanted to find theta, I could use the tangent function because the tangent is just the opposite side length over the adjacent side length. So the tangent of theta is equal to y over x. Our y is 7 and our x is 5. So the tangent of theta is 7 over 5. Put that into your calculator and find that theta is about 54.5 degrees. So if Z is 5 plus 7i, I could write that as the square root of 74, because that my R value times the cosine of 54 degree or 54.5 degrees plus I times the sine of 54.5 degrees